And welcome everybody to the Daily Space Weather Show. Filaments remain the story. Check that out. We'll get back to it. Make sure you stay tuned for that. Here are the past couple of hours from the GOES 16 SUVI. That was imagery from the SDO. And we've got plenty more to go. Massive prominence is rising there on the eastern limb, which would be your screen left. Our most active sunspot has been sunspot 3713, is it? 3712? I don't remember. We'll get to the names. They're arbitrary. Sunspots are just numbered in order that they appear or form. They got to be there over 12 hours, I believe, the majority of a day to get a name. Here's our SDO 304 angstroms. Again, note the prominences rising up over that eastern limb. So, despite an uptick in sunspot number and the X-ray flux, we've really got the major story remaining. Solar filaments. Here we've zoomed all the way out to show you all of those prominences. Prominences are when a filament is hanging off the edge of the solar disk from Earth's perspective. And that's pretty sweet, right? Anyway, thanks for tuning into the Smash News Network, least busted name in news. Make sure you press the like button. If you're new to the channel, press subscribe. Visit the links below the video after you press share, etc. Leave us a comment. Tell us how you found the channel. And a quick reminder, as a thanks to our viewers, it's less than a week until summer for the Northern Hemisphere. Or the winter solstice, if you're south of the equator. And we'll get back to solar imagery here in a minute. First, some stats. The 10.7 centimeter radial flux is now at 170 solar flux units. 170 is the current radio flux. There it is depicted as a black line on the 1-year graph right on the home page at, well, not the home page, solon.info/solar. So sunspot number here approaching 160, right around 160 is the sunspot number. Radio flux is 170. Sunspot number and radio flux are directly proportional, meaning when one goes up, the other one goes up alongside it. Now, the CME that we talked about yesterday, it looks like NOAA may be half-heartedly forecasting a geomagnetic unrest from it. So, interestingly enough there, you can see that indeed NOAA is agreeing with what I said yesterday, that we could expect to see that CME impact by midday on June 16th. So perhaps they saw the forecast. Maybe NOAA watches the channel, right? But it was a pretty stealthy CME. And guess what? There's another stealthy CME also on the way to Earth. This one's even stealthier. So it should be interesting. Now it looks like their Enlil spiral isn't really showing that. And interestingly enough, the European Space Agency, or ESA's Enlil spiral, is actually showing a coronal hole high-speed stream showing up. So that's, yeah, the ESA is not, it must be stealthy enough that nobody really happened to see it. So, yeah, but that's what happens, man. That's what happens. If you're not immersed in the data sufficiently, you might not catch things. So that's just the way it works. We've got geomagnetically calm conditions, and like I said yesterday, we're not expecting a major geomagnetic storm from that minor CME impact that we saw on yesterday's Daily Space Weather video. So there are the past 4 hours of Earth's magnetic moment from space, and it's chill, geomagnetically calm, with like a KP1. We'll get to that as well. Our ground magnetic perturbations map is great at showing you locations where you might see the aurora when we have geomagnetic storm conditions. It's still showing you where the aurora would likely to be seen. It's just that it's fairly unlikely to see the aurora, except at the normally associated locations at high latitudes. So, very calm right now as far as the solar wind parameters and the magnetic fields associated with those solar wind parameters go. KP index is actually 0.67, so below a KP1. And we've got a slow and diffuse solar wind, as measured by the ACE there, not even 2 protons per cubic centimeter at just over 350 kilometers per second. And at the Discover, Some anomalies showing up there on the Discover. Current conditions very similar, about 1.5 protons per cubic centimeter. A little faster solar wind there at Discover, 379 kilometers per second. Still quite slow, as below 400 is considered subnominal. Ghost magnetometers are chill. No surprise there, no major space weather striking anytime recently. Next we'll look at the heliosphere magnetism. Earth is moving toward another sector boundary crossing. Oh, there's some turbulence happening over there in the east. So keep in mind there are some huge plasma filaments rising as well. Those could be causing that. As huge plasma filaments, they have a tendency to obscure the magnetic fields that are behind them due to their extreme high temperatures and the magnetic fields that are associated with suspending them and defying the sun's gravity. So there could be a South Pole current sheet here as early as by tomorrow's daily space weather video. And it could be a very short-lived time in the South Pole magnetic sector as shown there in red. You can see some variations happening there at the fields. Here's our line of sight field plot. And yeah, that's pretty good stuff right there. It's showing a lot of information about what's going on. You can watch the solar cycle progress by watching this data throughout a solar cycle. You can even program it to show you all of that. That's the past 4 days. Next, coronal holes. We've got some more imagery of coronal holes. Actually, let's cut to some more SDO imagery here. So that's the coronal hole scenario. We do have one rotating in. We can expect to see a high-speed wind stream from that. It'll be fairly short-lived, and it's not going to cause any extreme space weather either, partially because of the proximity to the solstice. All right, so let's cut to some more sweet images here. There's our T-mass, our most active sunspot. That is where the largest solar flare, an M2.5 class solar flare, originated earlier today. The first half of that video right in there. Right about there was that M-class event. And here are coronal holes in SDO 211 angstroms. One of the many species of ionized iron covered by the Solar Dynamics Observatory. It's a pretty well-defined coronal hole. It's pretty close to the equator. You could say it's trans-equatorial because it is. And to me, that looks like if Mr. Peanut were an ostrich. That's what the shape of that coronal hole looks like to me. It looks like if Mr. Peanut were an ostrich. Yep. We'll get to sunspots here next. Sunspot number. Not quite at 160. 158. 158 sunspots is the current state of affairs. And the flare probability is very high for sunspot 3712. 3712 is where it's at. It doesn't need 2 turntables or a microphone. It's got complex magnetic fields and a close proximity of strong magnetic fields with strongly polarized umbrae. And that's what you want to see. That's why you see down there at the bottom that very high probability. A 50-50 chance of X-class solar flares, I would tend to agree. It's grown and become more magnetically complex since yesterday. Before we get to that stuff, let's cut back to SDO imagery. And as far as sunspot number prediction for tomorrow, it looks like we may have had a little bit of degradation in the south, but we've had some growth in the north. Looks like we'll have pretty flat levels of sunspot number moving into tomorrow, assuming that nothing drastic happens between now and then. Again, we do have some sunspots growing there just in the northwest. And a little bit of, they're mostly stable. They're mostly stable besides that. Also, the north central region looks like it has some new promising spots, so that's what's going on for sunspots. Here's our magnetogram. Let's get in a little bit closer to specifically show sunspot 3712. Because again, 3712 is where it's at. There's an extreme close-up for you. So that's the SDO magnetogram. And you'll see some very well-defined black on white areas there. Not half bad. And here's the continuum imagery, which to me, that sunspot looks like Krusty the Clown riding a broom backwards until he disintegrates while being sucked into that leading sunspot while being chased by some strange demonic entities. That's what I see. Let us know what you see in the comments. Sunspot 3712. It's our T-mass. It's T-mass, the most active sunspot. Oh, and once again, there's that magnetogram. And again, magnetograms, I mean, I guess I haven't said it in this video, magnetograms are how we forecast solar flares. Solar flares are indeed predictable. All right, so let's move on here. We'll get to flares and solar energetic particle events. The GOES proton flux here returning to baseline levels. The GOES X-ray flux, the largest flare of the past 24 hours, was, like I said, at M2.5 approximately class solar flare there. That was at 4:30 Universal Time this morning. And before we go to the solar system forecast, there is our 131 plus 94 angstroms SDO imagery. Your lower left would be sunspot 3712, the most active sunspot, the origination point of that M2.46 class solar flare. Again, that was at 4:30 Universal Time. If you want to go make your own movies, feel free. We put these together so you don't have to, as we bring you the world's most comprehensive daily space weather content and most detailed solar imagery in the known universe. Therefore, press the like button, or there will be ramifications. The solar system forecast may be altered through quantum mechanical means if you do not press the like button. Yes, quantum mechanics. People think it's magic, but it's not. Just take physics. All right, so here's our solar system forecast. There's where things are today. That's where things will be in a week on the 21st. That'll be the first full day of summer, by the way. Summer rolling in less than a week. Here's what's going on overhead right now besides major storm activity over Lehigh Valley. We've got Mercury and Venus and the Sun all bunched up together. Also Jupiter sitting there over our eastern horizon. Here's our astronomy photo of the day. And come with me as we climb to the top of Devil's Tower. Yes, Devil's Tower. It's a nebula that's rich with very dense hydrogen gas regions, as well as very bright, very rowdy blue stars. As you can see, those are causing emission nebulae there happening. That's why you get that crazy light effect. And you're also getting molecules and individual atoms excited by that ultraviolet light coming out of those ultra-hot blue stars. That's our astronomy photo of the day by apod.nasa.gov. It's part of the Rogers, Campbell, and White Oak catalog, number 85 in the RCW catalog. All right, let's get to CMEs. They're kind of important. CMEs, there was one today. It was even stealthier than the one we covered yesterday. You might not even be able to see it in this imagery, but it is on the way. So that'll be another CME likely to arrive on the 17th, or maybe late in the day on the 16th, but more likely on the 17th. So yeah, probably more like late in the day on the 17th. And it's really not going to show up very well here. I mean, we're better off just looking at the origin point, and it's because there are multiple outflows happening that are sort of masking it as a very good signal on this imagery. So that's just how it works sometimes. Stereo A will give us absolutely no help. Mercury and Venus are moving into its field of view. And the cool thing about Stereo A, folks, is it's going to give us a better and better view and a better ability to be able to forecast CMEs and their trajectories. So, once they eject, Stereo A will become increasingly helpful as it moves farther and farther to Earth's west and giving us a better and better angle of view on those CMEs. At the moment, not so good because, well, it's missing some of the latest data and it's not showing me the CME. This does not contain the CME you're looking for. So here is the There's our custom coronagraph. We got them all synced up for you there. And I would draw your attention to this active region once again. This active region. Can you see my pointer? I hope you can see my pointer. So it's just south of center disk. There was another stealthy CME that happened today. It'll be a minor impact, again, probably sometime late in the day on the 17th. I don't think it's high speed. Here's a closer view. And yeah, right in there, there was a CME. Some of the plasma splashed back down. Some of it undoubtedly blasted off. And when it's almost in the very center of the solar disk like that, folks, in all likelihood, there'll be some ejecta. So that's 2 stealthy CMEs in a row that we've covered 2 days in a row. And let's get the filaments, because those are super important as well. So yeah, filaments. There's a great view of filaments. There's an even closer view of filaments. And look at the size of these prominences after we show sunspot 3712 one more time, of course. You got to have that. And just look at that prominence. Let's zoom in one more step, just to give you a scale of how massive that prominence is. I mean, we couldn't fit the whole thing on screen at that zoom, but it's hundreds and hundreds of thousands of kilometers in length, probably in height, several tens of thousands of kilometers. It's on the big side. So here's Big Bear, and you can see a bunch of filaments there overlapping the disk. On the gray imagery, you can see a bunch of filaments off the edge of the disk. Filaments. They are extreme. They're the past couple of hours in the GOES 16 131 angstroms wavelength. And here come bonus features. Charging hazards are non-existent. The GOES X-ray flux remains at... Stop that. Remains at low levels. We're waiting for that to rebound. That should rebound sometime in the next 12 hours. There's the NOAA forecast. NOAA's not expecting it to rebound. So, I don't know. I disagree. I think NOAA's next forecast will be off too low. Next, we'll show the ionosphere, the layer where it's measured. Those electrons are located at about 300 kilometers of altitude at the F layer of the ionosphere. Here it is in vibrational frequency, the ionosonde by Australian Government Bureau of Meteorology. That's the previous day, and besides the South Atlantic anomaly having moved to 45 degrees west longitude, not a lot going on there. Here's the anomaly graph depicting anomaly in megahertz from a 30-day median, and as you can see, the South Atlantic anomaly is now on the 45-degree west longitude line instead of over nearly the center of the South American continent. So, facts. There you have them. We'll also show the Global Ionosphere Nowcast, which depicts total electron count and maximum usable radio frequency for you high-frequency radio users, like ham radios. There you go. And we are seeing ongoing anomalies in the anomalygrams. I don't know what's up with it. I'm not concerned about it. Here come the last images. There is the closest star in high res. And we'll close out with a close-up of this. So, likelihood of X-class flares, I agree, is like 1 in 2. It's about a 50-50 chance, maybe a little more than a 50-50 chance of X-class solar flares, especially from sunspot 3712. And also, don't forget to keep an eye out for filaments. Filaments. Those are some mighty big filaments. Anyway, I'm getting back in the bunker, folks, because I've been out for a long time, and phew, thank goodness I've survived another trip outside the bunker. So far. Anyway, we'll see you next time here at the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.